Welcome to the DoD Cloud Workshop. I'm Patrick Tucker, Science and Technology Editor at Defense One. Digital technologies, particularly cloud innovations, are a top priority for the Pentagon as it looks to the future of warfare. To stay ahead, the DoD has invested significant resources into cloud technology to allow data to be shared more efficiently across the service branches and with allies. Cloud will change how the Pentagon communicates, stores, and processes data, opening up new capabilities that may have seemed science fictional just a few years ago, but the technology is still evolving and there are many challenges to implementation. So I'm excited to begin today's event with EP Matthew, the Deputy CIO for the Defense Intelligence Agency. Can I call you Matthew?
You can call me Matthew. You can call me EP. You can call me whatever you want.
Okay, EP sounds fun. I like EP. So to start off, can you tell us a little bit about who you are and what you do at DIA?
Okay. Good morning, Patrick. My name is, again, EP Matthew. I'm the Deputy CIO of Defense Intelligence Agency. And here at the CIO at DIA, we do the full life cycle of IT. So from design, build, test, deploy, and maintain applications. This includes both hardware, software, infrastructure. So from wide area networks to local area networks, to applications, to implementing Active Directory, the full life cycle of IT is what we do for DI.
Okay, and for those of you that aren't familiar, the Defense Intelligence Agency is one of our nation's preeminent, and certainly if you look to the challenges in the geopolitical context today, a incredibly important and forward-looking intelligence agency. And one of the different benefits to having a very forward-focused, tech-forward intelligence agency is now we can get a sense of how lots of big data that comes from lots of different places all around the world might affect different DoD strands, strategies, plans, etc. So I wonder, as we look towards a future where a variety of different clouds, enterprise cloud at the high end, and also more smaller clouds are interacting with each other, and different people in different places are trying to pull data from lots of different sources, sometimes in difficult circumstances. Can you tell us a little bit about your plans for the DIA's future cloud architecture and how you're going to fit very large clouds together with very small clouds and everything that goes into creating that marriage?
Yeah, sure. So the first thing, our number one priority is, as you have, you're moving from a single cloud provider to 5 cloud providers. So previously we had just the Amazon cloud, what we call C2S, Commercial Cloud Services, which was provided by Amazon. We're moving from Amazon to 5 new cloud providers, one being Amazon, Microsoft, Oracle, IBM, and Google, right? So I think one of the things that concern us is, how do I build interoperability in that cloud, right? So there are 4 or 5 big areas that we are focusing on as we look into financial year 24, 25, and 26. Number one is what we call JWICS modernization. So what JWICS is the wide area network, the TS, the top secret wide area network for the federal government and the DoD and the IC. So the way I explain what JWICS is everyone remembers the killing of UBL, Osama bin Laden, right? And you see that iconic picture. On one side you had Allahabad, right, with our SEAL Team 6, and on the other side you had the White House, a picture of the White House with the National Security Team along with the president. Well, that connectivity, right, and that conference was done through JWICS, specifically supported by DIA-CIO, right? So that's what JWICS is. So it doesn't matter. You can have 5 clouds, 1 cloud, some big clouds, small clouds, unless you have that highway, the TS highway, it doesn't matter, right? We know this because we've seen this when you look at threats facing U.S. today, right, from Russia, China, Iran, and North Korea. We know the playbook. The playbook is to cut networks and infrastructure, right? I'm not saying anything classified here. It's general, you do go after command and control. We saw this when Russia attacked Ukraine. But the first thing they tried to do is take out the internet. So our first goal is how do we do JAWIX modernization? How do we create resiliency, redundancy, right? How do I create multiple pathways so that time of crisis, I have the ability to pass intelligence information not just to DoD members or IC members, but also to my partners, to my Five Eye partners, to my traditional partners and non-traditional partners, right? And so against that backdrop, connectivity is important. Number two, interoperability is important. So our number one goal is to do that JAWIX modernization. The second piece that's also important is you can have the cloud, but you've got to have the pathway to get to there, and that's what we call our DOTIS modernization. So DOTIS is our local area network and everything beyond, everything inside that network, right? So from your desktops to the local area network to reach to the cloud, right? So it doesn't matter if you have great wide area networks, if your local area network is small or obsolete. The experience, a user experience, is going to be that of the local area network. So the example I give over here, or the analogy I use over here is, I live in the DC area, and if you have greater than 8 inches of snow in the DC area, the metro shuts down. And the news comes on and says, hey, it shows the 495, our beltway. Look, hey, you've had 8 inches of snow, but the beltway is clean. Doesn't matter. If your local roads are not clean, you can't get out to that beltway, right? Your experience as an individual is based on your local roads. If you can't get out on the local roads, you cannot get to the highway. So it's the same thing. If your local land infrastructure, your desktop infrastructure is not modernized, right, you will never be able to experience the throughput connectivity of those clouds, right? So the next goal is to modernize that DOTIS infrastructure, our backend local area networks and the desktop. And this is a part of the cloud, right? Because you see now Microsoft offering Office 365. And so now how do we move from our local environments and adopt cloud-based technology onto our desktop? Well, against that backdrop, I also had to think of all my customers. For DIA, we don't just support the users at Washington, D.C., at DIA headquarters, but the J2s, the Intel components of all the combatant commands belong to DIA, right? And that's across the world, from PACOM to STRATCOM to UCOM and CENTCOM, right? Just to mention these big four, right? They're across the world. So especially when you see the crisis that's going on in Niger, right? How do I support that event? So I can't have cloud computing, the big clouds, in very specific regions when I might have to support a disconnected environment or a degraded environment, right? And sometimes cloud may not be a panacea in those scenarios. So how do I put in systems like cloud in the box, right? So that's our second goal. So JAWIX modernization, number one, DOTIS modernization, number two. But also, as part of the DOTIS modernization, we see increasing threats that are going on today that we never saw, say, 10 years ago. One unique common theme between both the private sector and the public sector is the security threats are the same, right? And so how do we now partner up with our private sector companies and how do we look to solve the security threats that are affecting the public sector, right? So one of the things that we will look to do from 24, 25, 26, and then collectively as an IC is the implementation of zero trust architecture internal to our environments, right? So that's part of our DOTIS modernization. And so we'll do the wide area network, we'll do the local area network, the desktop services, right? Adopting cloud technologies, and then also modernizing and increasing the security capabilities, leveraging zero trust architecture. I think the third thing we will do is also set up, the rapid development of software capabilities. So I think when you look at places like PACOM and other users, right? I think when you have cloud, the advantage is we can now move to a software-based software as a service, right? SaaS models. But there are also one of the things that we also need is the ability to rapidly deploy capabilities, leveraging the SaaS capabilities that exist, but maybe modifying or adopting, a couple of technologies from multiple cloud environments, right, and creating something unique. Well, so one of the things that we're looking to do and modernize is creating a software factory on the low side, on our NIPRNet side, and it is going to be available for the first time to our Five Eye users, or the Five Eye partners, right? So that means UK, Canada, Australia, New Zealand, us and Canada, right? So Five Eyes together, right? So we can jointly, collectively build capabilities in a rapidly deployed fashion. And right, so if we can simulate our high side environment onto the low side, right, and if we can do that, what it does is, and in a secure manner, what it does is we can build the capabilities as much as possible on the low side, and then just deploy it to whichever top secret fabric that we need to, and then do the integration on the high side. It makes it a lot easier. It enables us to attract software engineers from multiple different places, right? A lot easier to get, a CAC card or to build capabilities and to get engineers on the low side than on the TS SCI side. And I think one of our last goals, I'll start with our last goal, and that is how do we now integrate multiple networks together, right? So we don't want to build for US only. We want to build with the ability to share, and that starts from the design. How do I work at the international level? How do I build capabilities so that I can pass it from different networks, not just US only, but Five Eyes, traditional partners, and non-traditional partners, right? If you look at the unclassified, from an unclassified side, we have about 30 countries that are involved in Ukraine. That does not work well, right? Intelligence is only as useful as the ability to disseminate information. If you cannot disseminate intelligence, its value is proportionally limited by the ability you have to share, right? So the ability to share intelligence to multiple partners increases its value.
Okay. Wow. That's thank you for outlining those priority points for us. That's certainly a lot in there. I want to go back to a bunch of different things that you said, but let's start with this idea of cloud in a box and creating at the endpoint, possibly in even a contested environment, something like an enterprise cloud experience for people that can't access an enterprise cloud. Tell me how you see that building out, and how you create also zero trust security at that endpoint for that individual.
Yeah, I think it starts with the design, right? I think if you have those design principles, then you're just mimicking your enterprise services at that cloud in the box capability. There are multiple vendors, multiple cloud providers, multiple vendors that provide cloud in the box type capability, and that could be cloud in the box, cloud in a car, right? And what that does, it enables you for communication, enables for intelligence, enables for connectivity, right, to achieve the mission objectives in a manner. So we don't see that as a far stretch. Those capabilities exist, and we, in a contested environment, we intend to use those types of capabilities to achieve mission objectives, to support mission objectives.
And let me go back also to this idea of like merging all of these different environments together. I remember a few years ago covering the JEDI contract, which might bring up nightmares for anyone that's sort of familiar with it. But one of the strong arguments for going with a single vendor was that you didn't have to create a lot of kludge code to merge together somebody's product with somebody else's. So you didn't have to create kludge code to merge together, Microsoft and Amazon. And now it seems like we've kind of overcome that because we've embraced this idea of like the Five Cloud, which is dominated by AWS, but there's Microsoft is very heavy in there, and you have the other providers, IBM, Google, and Oracle, kind of at the edge. Is there a appetite among these vendors for creating new avenues into one another's cloud, or is that sort of something that needs to be led by you? Or how are you seeing all of those different things that are competing businesses beginning to interact with one another in order to assure reliable service, regardless of which cloud you happen to be on at any time?
Yeah, so great question. Again, I would say we are in the nascent stages of this. So one of the things that we have done internally is, in anticipation of a multi-cloud environment, we have purposely chosen to build things in an infrastructure agnostic environment, right? So what that means is if I'm building something on the AWS cloud or the Amazon cloud, I'm not going to adopt native cloud services where if I had to now transfer information or data, right, to another country that does not have Amazon, it would be inoperable, and it could lead to potentially interoperable issues, right? What I'm going to do is, so I would not use, again, I would not use native cloud services. What I would do is I'm going to build this capability on a platform that is infrastructure agnostic. So if I need to move that data, if I need to move that capability from Amazon to Microsoft, it would be completely transparent. Or I could move it onto my local private cloud, right? Because we also have our own data centers across multiple continents, right? And based on the mission need, based on latency, based on the environment, right? Degraded, contested, disconnected, I could move this in anywhere. So that is our approach to build it in an infrastructure agnostic manner, right? So I can move it to any cloud, I can move it to any location, and I would still get that interoperability function. I think the other aspect is you have to start thinking not just US and the features that you have in US, but if you're going to focus on working in an interoperable environment, right? Going back to the statement that I made that intelligence is, proportionally valuable to the ability to disseminate to multiple countries, right? Think of your Five Eye partners and think of multiple countries that don't have that don't have those 5 cloud environments, right? And if you start thinking in that manner, how would I pass data, right? And if you don't think in that manner of that infrastructure, in that infrastructure agnostic environment, I think you will reach a point where your unique solution, reaches a crisis or is not as used by others because of interoperability issues. Does that make sense?
Yeah, no, that totally makes sense, and that's certainly a huge priority for across the Defense Department, particularly in places that are going to be receiving a lot more attention in the years ahead. INDOPACOM. I just returned from a trip, and there's a lot of regional partners that are very anxious to do more exercising, not only with the United States but also with each other. It's kind of a first, as they kind of assemble something that's more like a unified posture and getting them all on the same page data-wise in a way that's safe and protects U.S. Interests is really key there. But we're talking about a lot of different countries that aren't used to sharing data with another. So you're creating, it sounds like a huge challenge creating the inroads between all those things that can share data agnostically. Kind of a dork question, but is in this agnostic environment, how is the data structured? Because these different platforms have different standards for structuring data depending on text or tables or pictures. How do you deal with non-standardized structuring of data?
This is a huge challenge for us, and this is something that we're also focusing on in FY24. One of the things that we're actually going to look to do is put the chief data officer for us as the chief of capabilities. Today and we're going to change that organizational change. And because what we've seen is exactly of what you said prior, right, in the previous generations. So we have been a very application centric, and we've built at DIA, we've been a very much an application centric environment. And as you move to a multi-cloud environment and a multinational environment, right, when you focus on places like China and Russia, you can't just go in by yourself. You have to be interoperable, not just within the US and within the IC and within the DoD, but within multiple countries, right? And so now you have to move from an application-centric environment to a data-centric environment. So this is where that software factory becomes so critical, because at that software factory, at the design, it's so much expensive, right? If you look at production level errors versus manufacturing level errors, right? If you build an application-centric environment and then you want to convert it to a data-centric environment, I would consider that a production level error. The cost of doing that to switch is almost 100 times, right? System engineering principles will tell you that earlier you find errors and flaws, right, in your design phase, it's 100 times easier and cheaper to fix it at the design phase compared to a production level error, right? So one of the things that we are looking to do as we build that software factory on the NIPRNet side is to set up data standards in the very beginning, right? Data cataloging, right? Understanding data provenance, all those things up front. And if you build those things up front, then you can build data that is tagged, marked, transferred in an interoperable manner, right? Today, we're not mature, that is one of our goals to do that in FY24.
Awesome. Yeah, that's certainly a heady challenge. One that I don't think people appreciate also involves a lot of human personalities. I remember the fight not too long ago between the Army and the Air Force on joint all-domain command and control, and who got to own the data standards, and that was a scrap. That was a bit of a fight. So this is there's a lot of human relationship building that goes into all of these decisions. I don't think people actually appreciate that as much as they could. But one of the big things that all of this environment building, resilience building, data standardization strategy is supposed to support in the future are a variety of different machine learning and AI applications, many of which right now just exist entirely a conceptual way. The Defense Department as a whole is only barely getting started on all of this stuff, trying to put in place fundamentals of ethical principles for dealing with data, actual standards, understanding use cases. But core to really implementing AI at scale are three things. You need the data which the Defense Department has access to, and as long as they're working with great partners, will have abundant access to that really critical data. And you need compute. And the third thing you need is just the mathematical formulations, which I don't know. I haven't changed that much since the days of Thomas Bayes. It's actually the least important part in many ways, and the compute is kind of really key to that. Can you tell us a little bit about how what you're building and how you're seeing artificial intelligence and machine learning being supported by what you're doing, and how you keep that future need in mind as you build this out?
Yeah. So let me go back and clarify or expand a little more on the data standards piece. We have pockets of excellence in which we have data standards established. So Mars would be a great example, because Mars is working with our Five Eye partners, and so we have Mars that's working on those data standards and doing those things. Holistically, across the entire enterprise, is everyone at the maturity of Mars? I would say no, right? And so those are things that we're looking to build and do that, right? And what you said is exactly right, that you cannot get to that artificial intelligence, or you cannot get to that machine learning unless you have those data standards, right? Because unless you have that, you'll be very limited. So we see things involving, we are the official targeting source for the DoD and IC, and so things involving with MIDB and Mars, right? Especially Mars is building on those capabilities. But with that intent in mind is where we start to develop those data standards and looking across the community and identifying those data standards. But also beyond that, when you go into zero trust, if you don't have those data standards, it becomes very, very hard to do that. So one of the things that we're going to focus on in Zero Trust has 7 pillars. And if you total those 7 pillars, there are about like 33 different subcomponents within those 7 pillars. And one of the things that we're going to focus on in 24 is the data standards, right? Is that data pillar. And maturing that, one, not only for machine learning, but more importantly for security, right? Because if you don't have that, if you don't have those data standards, what you will end up having is multiple siloed environments, right? Multiple SAP networks, multiple enclaves, right? And it creates a duplication of data based on an application-centric environment. So our goal is to build those data standards. And then once you build those data standards, it enhances your protection. It enhances data provenance. You create data standards, and you can eliminate multiple siloed networks, multiple SAP networks, right? It enables you to have Five Eye partners log in sitting right next to you on the same environments, right? And so that is our goal. So if you use, and you can translate this, right? Like if you simple AI is looking at if you take a picture, if you take a snapshot, right, and you look to try and identify a dog, I would say AI 1.0 identifies that dog in that picture. 2.0 identifies what kind of dog it is, right? 3.0 it identifies not only the dog but the vulnerabilities of that dog, right? And 4.0 it enables you to mimic and create and leverage that environment in multiple areas. So keeping it at the unclassed level, right? You can now extrapolate what we want to do, and we want to get to that. We want to get to that generative AI in the future, and so we are working on those things on the mission side. On the infrastructure side, a lot easier, right? Because again, on the mission side, it is we need to know the mathematic algorithms, because you could be putting warheads on foreheads, and so you have to be a lot more cautious in terms of understanding those models. On the infrastructure side, we have the ability to take on a lot more risk, and so for example, can I use those same machine learning principles? Can I identify pattern of behavior of a machine to identify when a router will fail, or when a machine would fail, when a server would fail? Can I look at things that I normally do not necessarily look at, like fan speed, to identify, hey, this device has a risk of failure, right? Can I observe its pattern of life and say, hey, chances are 3 months from now this machine could fail, and now can I prevent that failure using machine learning principles? And so we are working with multiple startups to identify those things on our network and infrastructure side. So we have two pathways going on. One is on the mission side, right? Again, to enhance our capabilities to either prevent or decisively win wars, and identifying right intel and produce that intel. And on the other side, on the infrastructure and network side, so that we can create a better operational environment so that we have less downtime.
That's great. That's very fulsome. But one of the things also that I want to focus on briefly in the little time that we have left, in building all of this stuff out, I think that every enterprise cloud provider has said something, not necessarily full, but something to the effect of their awareness of the supply of advanced microprocessors in the role that they play in their cloud offerings. The Biden administration has put forward a big sort of legislative effort to bring advanced microprocessor production back to the United States, but you can't have enterprise cloud at this level without the chips to kind of do it. So understanding that this is an enormous problem and we only have a small piece of it, is the supply of advanced microprocessors something that comes into your life at all, and are you beginning to strategize around secure supply of advanced parts for cloud computing architecture?
Yeah, I would say so. Before anything is touched onto our network, right? And again, remember, we own JWIC, so the entire TS-SCI network of the federal government, we kind of manage. We go through a very detailed process on something like this, because this is one pathway an adversary would look to get into your environment. And so those things are very important for us. Supply chain management is very important for us. And we've seen instances where we've seen things that are, that shouldn't belong on the network have been identified on the network. So absolutely, we see this as a critical pathway for us.
Yeah, great. Before we go, one more thing. Tell us just a little bit more about this software factory and how you see that actually working on the ground. Are we talking about kind of coders at the edge, which is something that the Army is sort of looking at, or people that are kind of from DIA that are deployed to within different intelligence agencies, or what does the software factory look like kind of in practice?
Right. So I think it starts out with two things. One with security in mind, and number two, the ease of the ability to get someone who has a computer science degree or a computer engineering degree or a system engineering degree, right, or the ability to code at the TS-SCI level, right? Chances are, I'll use my kids as an example. My kids cannot imagine an environment without the cell phone right next to them, right? If you work where I work, there is no cell phones. We are in an isolated environment. It's very hard to get software engineers inside a SCIF, and it's very expensive to get them inside a SCIF, right? So how do I build a capability? A capability could be built anywhere. When you look at this, even the capability we're in right now, you have no idea where this was built. This could have been built in India, for all we know, right? How do I build this capability at an unclassed level and bring in software engineers that they don't even need to know they work for the Intel community, right? They don't need to have a clearance, right? So they could be, for example, they could be in California. They could be, they could be anywhere. and I can give them access to a virtual environment. They can build the capability. What makes that information classified is the data behind the capability, not the capability itself, right? So I can hold the data on the high side. I can build the capability on the low side. I can mimic interoperability of the high side on the low side, build that capability, and then migrate it to the TS environment. We see that as building the standards right away. We have built number two. We see having access to the best software engineers, right? At the low side, we see having getting software engineers at a lower rate on the low side, and then we see if we build this collectively, we feel it'll be more secure if we build it and secure it rather than individual vendors that do it, right? That could be that could be threatened by a foreign nation or a foreign adversary or an individual hacker who may not have necessarily a secure environment.
Yeah, that's fascinating. That's sort of an aspect of this years-long ongoing conversation about classification and the role that it plays. And I'm used to hearing Defense Department and other official leaders talk about the need to classify far fewer things and the need to move classification much faster. But I hadn't really considered that there's this other aspect to it, which is finding workarounds around the bureaucracy of classification, and that could possibly prevent a lot of delays and also enable much faster workflow if you can just actually move the process of creating around that big bureaucratic obstacle that stands in the way of data transfer. So that's something I hadn't really considered before. Well, thank you. This has been incredibly illuminating, and now I have a much better sense of everything that's going into helping DIA to build all of these future architectures and enable much faster intelligence sharing across really all allies and partners, but certainly across the United States military.
Can I add one more thing?
Sure. Yeah.
One of the things we're also looking to do this coming year in 24, if I can put a plug in for my HR brethren, we're also looking to modernize our HR capabilities, right? Ideally, we would love to be in a SaaS system, right? A software as a service system. But we understand the challenges with that, especially for an intel agency. But if there is a software-based or SaaS-based or next to, not necessarily a perfectly SaaS-based, but some kind of hybrid environment, we would love for them to contact us and work with us because we're looking to modernize our HR system as well in this coming year.
No, that's great. There's been tech layoffs out in California, so somebody's hiring. Get your resume in. EP, thank you so much for joining us today. Stay tuned, everyone, because following a short word from our underwriters, my colleague Warren Williams will talk with DISA's technical director about the DoD's cloud capabilities and JWCC. Thank you.
All right. Thank you, Patrick.